Welcome to Machine Minds, where technology and humanity meet. I'm your host, Greg Terrusian, founder of Samson Rose, a recruiting and search business focused on the robotics and AI industries. The Machine Minds show is where we dive deep into the intricate world of robotics and artificial intelligence. As a staffing industry leader with a passion for the frontiers of technology, I'm pleased to be bringing you intimate conversations with the founders, investors, and trailblazers who are at the heart of the AI and robotics revolution. In each episode, we dig into their journeys, the applications of the products they're working on, and the breakthroughs that are shaping our future. Join us as we explore how these machine minds are transforming the way we live, work, and understand our world. Whether you're an entrepreneur, a tech enthusiast, or just curious about this amazing field, you'll learn something new with each episode. Let's delve into the extraordinary. Let's delve into machine minds. Hello and welcome to Machine Minds. I'm your host, Greg Terrusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Rachel Sinclair, founder and CEO of Simuli. Thanks for being on the show today, Rachel.
Thanks, Greg. Happy to be here.
Yeah, my pleasure. Let's jump into it. So look, Rachel, you've had a strong research background before starting Simuli. Can you start by sharing a bit about your background, some of the research you worked on and that you were involved with, and what initially drew you into the field of AI?
Yeah, it's actually a good story because I kind of always knew I wanted to make a big impact, and I thought a good way to do that was locally. So I studied how to do kind of medicine and impact the people around me on that level, and I thought that might be a good career choice. And somewhere near my last senior year of undergrad, I just happened to accidentally basically walk into a lecture room where my later advisor was giving a talk about AI. And my mind was just blown. I was like, this stuff is really powerful. This is really a way to change the world and reach a lot of people. So it was very obvious to me, this would affect every industry. This would affect medicine. This would affect consumer markets, everything. So I figured I could tackle a lot of things if I had this base knowledge. So I began kind of just showing up at the lab, and they were very generous and very kind to teach me. When I showed up there, I didn't even know how to open a terminal. I didn't even know what a terminal was. I was kind of just like, this is really cool. I want to learn it. I have no idea, but I will just watch you until I absorb. So I had some really nice advisors who were great teachers, and basically, I just kept showing up. And I kept studying and I kept applying myself and building models. And once I built quite a few and explored quite a few regular models, CNNs, LLMs, to big research questions, I kind of got hungry for where is data from Star Trek, right? How do we get these next generation things that help us explain ourselves and understand ourselves? And it was apparent to me that we weren't going to get that in the current deep learning systems. We might get something that is really useful and can be applied to specific problems, but nothing that's really going to tap into what is consciousness and how do I explore that with a machine. So I started looking at, I did a consciousness postdoc, I did a PhD postdoc, and I started looking at kind of different neurological models of how higher cognition works and how consciousness works. And I really liked the explanation of how these systems come together at different levels of understanding from this Australian university professor, Andrew Coward. And I contacted him and I was like, your theory of higher cognition is really interesting. And I spent a couple years really learning it. And that's about the end of my PhD. And I was like, I can't find any counter evidence to say that this wouldn't work in a system. So I got really interested in trying to develop that as a new foundation model, an AGI project. But obviously I didn't want to do this alone because there's big research questions to answer here. So I formed a company to kind of assemble a team to work on these big questions and build this device.
Amazing. So that was your transition from research and academia into founding your own company. Not I want to say probably not the route that everyone would go down. They'd probably just stay in research trying to figure it out and things like that. What was the drive there? Did you always know that you wanted to be an entrepreneur? Did you always know you wanted to go down the commercial route?
No, I honestly never thought about it But the lab I was in was kind of specifically designed to empower and encourage people to go that route. Like kind of
Okay.
like it was very self-directed and very like empowering that like you can build anything you want. So the reason I decided like a company would be better than academia or government or another avenue was like to start was because there's some core unanswered questions of how do you implement this system in the best way, and moving at a fast pace and doing this in a safe environment where the AGI wouldn't like have to be open source and we could like use it offline, and there's like a trusted hierarchy of how do you market, make sure you don't actually develop something dangerous. It made more sense to kind of assemble a team of people to help. And that sounds like a business, right? So I like jumped right in, and at first it was like it's really scary because I'm a PhD student. I'm like I'm fresh out of a PhD. I have this crazy idea, but after a while, like it makes sense, right? You have a team to help solve problems.
Yeah. Yeah, that makes a ton of sense. Were there any pivotal moments or key experiences that solidified your decision to start Simuli instead of thinking like, oh, I'll join somewhere else and see if I can research it or look at it with an existing framework or a company that already has, resources and investment and things like that?
Well, I tried to do that,
Oh,
but
okay.
there's like at the time there wasn't a whole lot of companies hiring AGI developers, and
Mm,
I really didn't want to work on applied models like that. I had lost my interest. I'm very interested in kind of do this philosophical question of can we have conscious machines? And no one was hiring for like conscious machines, but like people would think you're crazy if you said that at the time, right? So I basically like tried to convince other companies like to work on the system, but normally they got funding to work on a specific system. So I figured if they can do it, like this project deserves that time too.
yeah,
So yeah, it was worthwhile, and I had a lot of encouragement from my advisors.
great. All right, let's break it down. And obviously for our listeners who might not be familiar with Simuli, what you do, the technology behind it, but in layman's terms, what is your technology? I know you recently were demoing some of it at a conference. And what is the goal here with what you're working on?
So all of our technology relies, well, not all of it, most of our product technology relies on a system of math. It's just like normal math, but it's a different language of math called hyperdimensional computing. It was invented by Pinti in the 80s at Redwood Institute. Um, this math is called hyperdimensional computing because it's projecting things in like a holographic state. And it's difficult to explain to like people because you either have an intuition for thinking about like a million dimensional like graph space, which is like quite uncommon, or like you have to kind of like understand like pseudo quantum machines and like how things can be like zero or one or not one, like how you can have collapsed states. So basically what you do is you project all the data that you have, like say for a machine learning model, to this like major graph, like this major space. So you extrapolate it, you blow it up, but you convert it to all the same format, zeros and ones. So when you want to like make associations between the data and learn things, all you have to do is understand the relationships of where they landed in that major space. It's kind of like if you like are navigating the stars, right? Like there's stars all over, but are these two stars more similar because they're closer, right? Like that's the type of questions you're asking. Um, and what's interesting about this technology is it's very lightweight. It's very efficient because it's all zeros and ones and like close to the metal operations. So if we can use it for AI, which is why we're building these products, essentially we can compute AI in compressed form. And that makes things a lot cheaper and it allows AI models to kind of flourish and share with each other. Like right now, if you want like a chat GPT and like a major like YOLO device for face recognition and chatting like on a robot or something, you almost have to use like cloud compute because there's no way that like you're going to be able to like put these like mega models on device, right? But if you had like a system like this, it becomes cheaper to where you could potentially have it on a mobile phone.
Really? Wow. And so what's been the bottleneck prior to this? Why haven't people been trying to, is it just like they haven't cracked the code or
I
what's been
think
the issue?
it's a combination of things as it usually is. hyperdimensional computing, one is difficult for some people to understand. So it's not as like you're learning a new like form of math. Like it's functionally complete. So anything you can do in like lambda calculus, which is the math language of regular AI, you can convert to this language. So basically, you can do all the same stuff. It's also quite new. So like first, you have to barrier to entry of understanding it, and it's like new in the terms of like it's still an academic like research phase. We're pulling it out of academia. We think it's time to like get some industry testing, and
Yeah,
it's too important of a solution to leave in academia. So like there's that barrier of like we're the first ones kind of heal
got
it.
it.
I mean, I think Numenta works with hypervector models as well, but there's kind of like few pioneers to bring it out of industry. And the major point is hardware. Like it really deserves what we call like non-von Neumann computing. So you need kind of like the hardware is finally getting to the point where we're getting these new like chip devices where it would make it faster to compute.
Got it. So it's that convergence right now. It's the right time for it.
Yeah, and the hardware is not essential. We can run things on, normal stuff. But if you wanted maximum efficiency, like how do you make AI training and inference cheaper maximally? This system would help a lot if it had special hardware.
Of that. Okay, very cool. Um, and talk to us about the consciousness element of that. Does that tie into this as well?
Yeah, so basically we so Andrew Coward calls his theory of understanding higher cognition in terms of anatomy and physiology recommendation architecture. So we are building a model with his help on, we call it rearc. So in rearc, there's some kind of fundamental questions of how do you like organize the brain structure? Like your genes carry that information. And we don't have like full like resolution to kind of snapshot image that and rebuild it in a computer software program. Um, so one of the like there's a couple of challenges, like that's why we made the company, right? The couple core challenges, one of them is like keeping this record of every neuron that fires at the same time as everything else, right? And if you just did that like in a very naive way in software, you just make a list. Like you just write down every time like something fires, well, like what time it is and what fired. And that's gonna get like infinitely long, right? Like you're gonna keep adding to the list. So that's an issue in software. Like how do we encode something that in 3D space is written in the brain in software? So a good kind of band-aid approach to like an infinitely long list, because it's kind of a difficult problem, is using like quantum computing. Like you can like store data and collapse the state when you need it. But like quantum computers for an AI, like is too far away. So we'll just use pseudo quantum. So that's where we found HTC math to plug in to solve a specific problem. Now, how this all fits together for like a company like Roadmap is if you have like large data centers where that are storing like data for AI, you would want to encode all of the data in a format like ready to be computed by whatever AI, like your AI model or the rearc. And we then developed a package to convert your like whatever, like if you're using a CNN or an LLM to like the math of hypervectors to compute on the compressed data. So you can bring your own model, any model, or like some people they're not going to want to like we want to introduce a new foundation model that's multimodal. So you can use our like early versions of rearc. So these kind of three like toolkits work together like on a large scale AI compute to make it training cheaper.
That is powerful. And in terms of timelines, we spoke about this offline, but when do you think this is going to start coming out? When are you going to allow people to start using it?
Yeah, so we have early kind of proof of concepts and the like necessary components to like put this all together in a like industry level package. Um, I think for consumer level like use of this technology, it's quite a ways away. I mean, it could come in some like different form, like depending on hardware and things like that. But our kind of product rollout is kind of get like a system all architected, and rearc will come later because building a foundation model takes a while,
Yeah.
and we're focusing on like how to get to market and how to get people introduced to this technology. and get like over the infrastructure hump. So we roll out Nebulae probably like Q2 of next year. We already have like a working version of that, and we're just making it better. And that like stands on its own because it saves memory. But like the key value there is that really what you're doing is you're making data AI ready. You're removing some of the pre-processing because you're just storing in a like general format. It's kind of like when you, for like techie people, it's kind of like when you format a hard drive. It's like NTFS or like exFAT, right? You're choosing like a general format for like a specific like purpose. So that will kind of like have its own go-to-market strategy, but it's really part of how you feed data into an AI model, which goes into our Supernova platform. So Supernova is the actual like one product that makes this whole infrastructure work, and it uses Nebulae to like digest the data. And product rollout for Nebulae will follow, or for Supernova will follow Nebulae soon after, like Q4 probably. And we want to be general, right? So we'll have to like build up devices and different models like over time as product features.
So
So
it's going to be Simuli, sorry, Nebulae first. Yeah.
yeah,
And then it's going to be Simuli,
Supernova. So
Supernova, sorry. And then
Supernova is
Arc
the
later on.
infrastructure. Yeah, sorry.
Yeah. Yeah.
Yeah, it's just that Nebulae has an opportunity to kind of start the like it has its own value and it has the opportunity to kind of start like getting its way into the servers to help with
Amazing.
data.
Yeah. You've got to do it gradually, I think. And then that helps with adoption, right? Okay. Awesome. So as a company, you're obviously still in the early stages. I know you've got these big milestones coming. We spoke about potential funding. We're talking about this, the releases Q2 next year. What have been some of the biggest challenges for you guys so far at this early stage?
Um, we're really doing something that's like truly innovative. I know a lot of people like a lot of stuff is innovative. Otherwise, like why are you doing it?
Mhm.
Like from it's hard to go to market with something that you're not innovating on. But we're innovating like at every like from the core level up. So we started with kind of there's no basis, there's no like Stack Overflow, there's no like app or API that like we cloned and then built off of. Like we had to like figure out the math and logic and then build the code from there. So it's always fun because we're kind of like chasing this trail of like we're bringing something into existence that didn't exist, and sometimes we encounter like a problem, like we know how to do it like logically, but it becomes an engineering problem of how do you like actually put this in a computer. And it's always fun because we go back to theory and we go to math, and we kind of walk our way down through the processing pipeline. But it's always like you're always like finding something new out about like the HTC math that hasn't really been reported, and we're like, that's really interesting, but beside table.
Yeah. Yeah. That's got to be tough. You're almost like educating people or educating the industry as you go along and trying to convert viewpoints, convert users, and having people adopt your ideas.
Well, the idea and why we like made this general purpose, kind of like two-part data model infrastructure approach is because we like it's going to be way too much to like it's trying to teach compilers the operating system logic to like everyone who uses a computer. Like you don't need to know like how we're making it more efficient under the hood. Like you don't need to know the math.
Yeah.
We just want you to be able to like use it with anything you're trying to use, right? So it's a little like when people are like explain it, I'm like, okay, like I'm happy to like sit down with you, and we have great engineers that are like better at explaining it. But we realized very quickly like this needs to be a plug and play, easy to use because no one
Yeah.
wants to sit down and like learn math.
True, true. Yeah, yeah, you see that a lot with some of the best products. They're the easiest to use, like from the start. You don't need to do too much configuration. You don't need to understand how it works. You don't need to go through a manual. You don't need to do all of that stuff, get extensive training. It's just easy to get up and get going, or switch between what you're currently using to the new thing. I think
Yeah.
that's what stops a lot of people transitioning.
Yeah, I think that's what was like really innovative about OpenAI. Like they had GPT for like infrastructure for a long time, like the core code. but
Mm.
they figured out how to make it easy to interact with from like a general public use. And
Yeah.
like that in itself was a huge innovation. Like before that, we didn't really have a way to like, as a normal person, interact with a powerful AI.
Yeah, it's true. And everyone's used to that, like from Google, right? Your search bar, the search window kind of thing. And if you have an interface that people are, it's not exactly the same thing, but already used to, adoption is going to be a lot easier.
Yeah, like for the most part, I feel like a lot of people didn't realize how much AI is in Google search. Like Google search is like a good example of like
Really?
we're hiding like the complex stuff, just search.
Yeah. Yeah, that's true. Um, can you tell us a bit more about like the conferences and stuff that you guys have been involved with recently and where you've been speaking and uh, sharing your insight?
Yeah, we recently spoke at it's the Singularity Net event in Thailand before DevCon. And basically we were just like socializing the ideas of decentralized compute. So I spoke on a panel about decentralized compute and why that's important for something like AGI. And for anyone who's like not technical, like AGI is basically a vehicle for like a next gen system of AI that's not like application specific, that has higher cognitive functioning and like some aspect we can like recognize, right? People have different like versions, but I think that's kind of umbrella enough. Um, so there's several ideas for like how to get there to AGI or like even start to get there. But the what we've seen, and Bangers was like very like a good example of a company that is kind of leading an approach in this direction. We've experienced that as AI grows, it scales up with large compute. So you either have to like make it like vastly cheaper and easier, like hardware wise and resource wise, to do what it does, or you have to like find a way to meet the hardware demand. And so that's like efficiency and resource consumption is kind of the central role of what we do. Like our reorg model is all about like resource consumption, like how do you allocate resources? That's part of learning. And our products are like how do you get more efficiency by optimizing the code, right? Because that's kind of like a problem that's been overlooked in AI is memory is cheap and like GPUs are interesting. So we've just like thrown massive power at it.
Interesting. Okay. Um, let's jump forward. What if we look back, or if it's 5 years from now and we're looking at the journey that Simuli's had, what impact do you hope to have had on the industry?
Um, 5 years from now, like our goal is to have our rearc model like moving towards a phase of exploring some very interesting like higher order cognitive processing. So when we introduce this like new foundation model, a good kind of stepping point is to start with a multimodal system. So how do you integrate different sensory like inputs like audio and visual, or audio and lidar, or whatever the industry needs. But as we move the system up, we want to get it to start its own like autonomy. Like one issue with like AI transforming to AGI is how do you get the computer to like do stuff on its own? Like how does it know when to do stuff and when to stop doing something and do something else? So that's kind of the system that I would hope that we would create, and it would start to give some like very interesting like agency like cues. Like you would see it doing things on its own in a way that like was not pre-computed.
Interesting. Very cool. Let's talk about your entrepreneurial journey, because as we discussed initially, from academia and research into entrepreneur, not always the easiest transition. But as a founder, what have been some of the most surprising lessons that you've learned on this journey so far?
Um, I feel like I'm not qualified to like make. I mean, the journey's not over, so
Of
it's
course.
hard. Like I can only speak from my own experience, and what works for me. It may not like work for everybody. I think what I've like really learned is a lot of like how to build stuff with other people relies on like how you treat people. Like if you're
Right.
building like something that you want to be a good product that helps the world, you should do that in a way like where you communicate and build with people that you like value, and like how you like exist and communicate, like build who you're building with and how you build it, like it's going to be reflected in the product itself. Like you can't like you're going to put your human element into the software at some point. So you should do that in a way that I mean, like for us, it works in a way that we try to be kind to each other, right? Like we try to trust each other and be nice.
That's great. That's great. And is there any advice that you'd give to aspiring entrepreneurs in the AI field specifically?
Um, I think it's always like as a scientist, I still like claim as a scientist. I think it's always good to like check what's out there first. Like do your literature review, like make
Yeah.
sure like there's not something that you can like take and quickly adapt. Like you might be able to get to your goal faster by like working with other people. And also just like to be confident, like to just try, right? I think a lot of
Yeah.
people like they have great ideas and they want to go for it, but they think like I don't have a business degree or I don't know what to do. And like you can learn along the way, right? You can find people to help you.
Yeah. That's really good advice. Both of those really good advice. Yeah, doubt and fear kind of kill more ideas and before they've even started, right? So that's really good advice. Are there any strategies that well, before we jump into that, let's shift gears 'cause I'm thinking bigger. You're working with a lot of people. You've got some advisors. You've got some people helping out here, but you're obviously going to need to build a team as well. And I know that you've recruited some people. So at this stage, how important is that? Finding the right people, retaining strong team members, and having them bought into what you're doing in the big picture.
Yeah, for me, that's why I started the company because I wanted a team to like help me build it. Like I knew I couldn't build it alone and it would be a richer like thing to give to the world with different perspectives. So like I started the company alone and got kind of a lot of infrastructure and started pulling in like key members like our COO Benoit who like is very good at kind of taking products to market, which would be helpful in this journey. And we kind of set up things in a way that was like very good to do with a small team. But the moment we put together like a team of engineers and like mathematicians and kind of really started working on the problem, like the company felt real. Like felt like we started making like real progress and bringing things into the world. And I mean that's a big milestone. Like that's
Yeah,
is like on your journey, right? So it kind of felt like without the team, I wasn't really like I was just setting things up to get the team.
yeah, yeah. It's great that that was always the goal. Are there any strategies that you found effective in building this kind of team and motivating people?
People like to work on what they like, right? And it's like if you don't know what people like and their interests are, you like it's gonna be hard to like get people motivated to work on the thing that they don't like, right? So I always try to find people who like are want to work on the things that we're working on. Like share like it shouldn't be competition, it should be collaboration. Like, oh, you're interested in this too, like let's work together.
Yeah, yeah, that's true. That's fair. Um, let's. Oops, sorry, just knocked my microphone. Uh, it, on the broader side of AI, if we're looking ahead, are there any trends and advancements that you foresee or that you're kind of excited by?
Well, I'm obviously excited about like our once our product gets kind of integrated large enough in the infrastructure, I think it'll give like it'll change things in the way that like it will give power to like people who didn't have access to AI before and kind of change model dynamics and how
Mm,
models can work together. So obviously I'm excited about that. But I kind of like a larger theory base where like people are starting to wake up to the concept of making bigger models is not like a long-term strategy for increasing model intelligence. So like we're already starting to see that like you can't like we're gonna run out of compute. Like it's already like climate not friendly. We're tapping out electricity grids, building servers. Like we're already running into problems. And the returns we're seeing in like what models can do are better, certainly better, right? But not like scaling like it's not as good scaling paradigm for like continuous growth of AI.
yeah,
So I think there's some very interesting strategies that are developing for like how do we tackle this from like a hardware perspective or a software perspective like us, or from like a completely new perspective on like how do we get users or like infrastructure and the actual like human element of it to help. So I think that's going to really change AI.
yeah, yeah. I definitely see that. There's often this debate about ethical implications of AI, and people that aren't in the industry or more naysayers or concerned general public have a certain view about it. And again, we spoke offline about some of the issues and things that have happened recently that people are aware about in the press. What's your take on the responsibility of companies in the space to ensure ethical practices and safe usage and things like that?
Yeah, since we're like also interested in developing, like we want to contribute to new foundation models that are smarter and more resource friendly. Um, we have a huge concern on where that model goes. We have an alignment team that works with our cybersecurity team that's kind of trying to implement a pathway that other companies could follow in the future of like how to be accountable to your own decision making. So it's good to like track when you made a decision about going left or right for something that could potentially be like a ethical or security concern in the future, right? Because what you want to start to get in the habit of is thinking about like because a lot of times you make an engineering decision and in the moment like you like are you like you're using like Python or C, right? You don't really like interpret or think about how is this going to like affect my users? Like can my users exploit this in a way that would make the AI harmful? Like that's a lot to process for an engineer who's just trying to like write their code. So we have like a AI team that kind of like points at systems and be like, that might be a red flag. And then we discuss and kind of work through it. But I think that's critical. Like we're a very like early stage startup and like from the get go, we want to be accountable for like making sure we build something good.
Yeah.
It's disheartening to see kind of like the AI ethics team on a lot of like large companies get like blamed after the fact. Like they should be in the process of building, right? Like
Mhm.
you shouldn't like evaluate a system like after you built it. Like
Right.
when you're planning and during building, like that's the time where you're going to make these decisions that might be like key failure points or in an ethical term, or like just not thinking about it at all is like quite like irresponsible. And I think legally we're seeing like that kind of sync up of like if you don't think about like how this could be used badly, like you might be in like trouble for how someone uses it, which I'm not saying is right or wrong, but it's like definitely kind of everyone is waking up to this responsibility.
I think it's moved so quickly,
Mhm.
the user adoption, the advances in technology, the different use cases, different products out there, and people didn't foresee some of that. Not that that's an excuse, because like with any system, if you build a software without security and safety in mind, for example, it's very hard to retroactively go back and sort it, right? You speak to any security team, information security team, they say the same thing. Same with ethics and stuff like that. If you're not building it in an ethical way or how it can be used, then it's very hard going back to fix that.
Yeah, I think it's also hard like as like even one person or a small team of people to like assess every single way a person could use this product. Like it's like people are very creative and like they find ways to use your product in like systems you would never think about, especially for like consumer level stuff for like general public. So it's kind of like a big responsibility on a single
Yeah.
person. Like here, like make sure like there's no possible way for this code to like be exploited. Like that's very hard, right? So I think we kind of need some system of like helping people make these decisions.
Yeah, that's fair. That's fair. Um, Especially if your mind isn't like that, if you're not if you're not thinking the worst, it's hard to see it. Uh, what's your view on AI and surpassing human intelligence and safeguards being put in place there to manage that?
I feel like it's a difficult question because you first have to address like semantics. Like
Yeah.
what's everyone has a different like version of what intelligence is. And I would say like by like a lazy definition of super intelligence, like we've already passed like human abilities on certain tasks.
Okay.
Um we struggle in like areas of like anything that's truly autonomous, like that's not just doing one task, like that can switch between like task domains and like sensory input. We're not great at like integrating large systems in a way that has like a AI based control. So if you had like a bunch of like in robotics, like it's difficult to like take a bunch of sensory inputs and possible model outputs and like very quickly compute like a recommendation of what to do. Um, even if you had something like kind of choosing what to do, it wasn't autonomous. Like it's hard to integrate information in AI because it's supposed to be like task specific. So these challenges, I think, um, like that's what I would want in a super intelligence, right? Like a super intelligent AI. I would want something that is like kind of, and everyone feels differently about this. Like I would want something that like reflects what humans are, but also is like quite obviously more. I mean, it's hard to like think about that though because their processing would probably be much faster. So like there's a lot of things that unravel from that.
Yeah, yeah. It's true. I mean, even to that point, not one person has all the knowledge of the internet in their mind right now, and with a few clicks of your keyboard, you can get the answer to almost anything, and that is in some ways more intelligent. But to act on that and to do things like you said autonomously, that's where it gets a little bit fuzzy.
Like it's good to like have like extreme knowledge, but knowing how to use that knowledge, I think is like the wisdom that we would want in like more advanced systems.
Very true. Yeah. Well, look, Rachel, it's been a real pleasure having this conversation with you, getting your unique insight, input, hearing about what you guys are working on. Cannot wait for what's to come. Really excited for you. Are there any final thoughts or things that you want to share with our listeners before we wrap?
Yeah, I think just stay tuned to see, you know, what happens next and kind of how we unroll this. And I this was a fun conversation, Greg. So thanks for having me.
My pleasure. Where can people find you and Simuli?
Right now, I mean, we have social medias, but since we're product focused, the best place to get information is just simuli.ai.
Perfect. We'll link that in the show notes. Thanks again, Rachel, and I look forward to keeping in touch.
Yep. Take care.